Alright, so welcome to the seventh problem. This problem is going to be about experimental procedures. We'll be presented with an experiment that was carried out and the data obtained from it, and we'll be asked some questions regarding the procedure and the data itself. So the problem says the following. Two students were carrying out an investigation into the chemistry of domestic bleach purchased from the local supermarket. Part of their study was a volumetric analysis to determine the concentration of hypochlorite ions in the bleach. This analysis was carried out using the reaction between the hypochlorite ions and the iodide ions to produce iodine. Now the experimental method is presented. First, the bleach solution is diluted by adding 25 centimeters cubed of the bleach to a 250 centimeter cubed volumetric flask and filling up to the graduation mark with distilled water. Then 25 centimeters cubed of that 250 centimeter cubed solution is reacted with excess potassium iodide, and the iodine formed in the reaction is titrated with 0.1 mole per decimeter cubed sodium thiosulfate solution using starch as an indicator. The equation for this reaction is given, and the color changes from blue to colorless. So we also have the results that were obtained. We have final and initial burette readings on first titer, second titers, and third titer. And the questions, which are first, to calculate the average volume in centimeters cubed of the sodium thiosulfate required to react with the iodine. Second, to calculate the amount in moles of thiosulfate that reacts. Third, calculating the concentration of the hypochlorite ions in the diluted bleach solution. And fourth, calculating the concentration of the original bleach solution purchased from the shop. So let's get to part A. It asks us to calculate the average volume of the sodium thiosulfate required to react with the iodine released from the diluted sample of bleach. For this, we will be using the data that's given to us in the table, and we can tell that we have three titers, the first, the second, the third, and we have the initial and final readings of each of them. Now, normally, if we were to run an analysis and calculate the average, we would take the average of the differences of each of the trials, each of the titers. However, the first titer is normally considered rough and is not taken into account for when averaging and getting a result to be able to calculate with. So in this case, the averaging is going to come only from the second and third titers, as the first one is considered rough. So the average volume is going to be the difference in initial and final burette readings from the second titer. We get that by subtracting the two values, plus the difference in initial and final burette readings from the third titer. Again, we subtract those two values. We add those two quantities, and then we divide by 2 as there are two trials that we are accounting for. So that would be, for this second titer, 46 minus its initial reading, which is 23.95, and then plus 22.15, because 22.15 minus 0 is 22.15. We add those two and we divide it by 2, and we get that the average volume of sodium thiosulfate required to react with the iodine is 22.1 centimeters cubed. Now let's get to part B, as we've already finished part A. Part B asks us to calculate the amount of thiosulfate that reacts with the iodine. Now for this, we're going to use one of our most essential equations, which is moles equals concentration times volume. We have that concentration of thiosulfate and it's already in standard units, it's in moles per decimeters cubed, so we can just go ahead and put that 0.1 in the C variable of the equation. We also have that volume of thiosulfate, which we obtained in the previous section of the exercise, that average volume required. That is going to be our volume value. However, it is in centimeters cubed, and it must be in decimeters cubed, so before calculating with it, we will divide it by 1000 to have it in the correct unit. So in the end, moles is equal to 0.1 times the quantity of 22.1, our average volume, divided by 1000, and we get that the amount of thiosulfate that reacts with the iodine is 0.00221 moles. And that'll be the end of part B. Now, part C asks us to calculate the concentration in moles per decimeters cubed of hypochlorite ions in the diluted bleach solution. Let's remember that this experiment has two parts. The first one is the volumetric analysis to determine the concentration of hypochlorite ions in the bleach, right? And that is described with this equation reaction. And the second one is the titration of that iodine that's formed with the volumetric analysis reaction, which is given by the second equation reaction. So we're going to have to run analysis of molar ratios on both of the equation reactions, and be able to, in order to be able to get that concentration of hypochlorite ions. So first, let's look at our base point, to say it like that. Our base point is that iodine. We have it as a product in the first equation. We have it as a reactant in the second equation. And the coefficient in both of the equations, which are balanced, of that element is the same. So that is like our base, no? So first, let's analyze the ratio of those hypochlorite ions, which are the ones we want to figure out the concentration of, to that iodine. The ratio is a 1-to-1 ratio, as we can tell that the coefficients of the hypochlorite ions and the iodine that is produced are the same. They are both 1. 1 mole of hypochlorite ions is reacting to produce 1 mole of iodine. So that would be our first molar relationship, which is the 1-to-1 relationship between those hypochlorite ions, which are the ones that we need to obtain the concentration of, and that iodine. Now, having that said, we can also get a useful molar ratio from the second equation, and it is the ratio of iodine to thiosulfate. Why? Because this iodine here that's being produced and released is the same iodine that's being titrated here. And we already know the amount of the thiosulfate. We calculated it in the previous exercise. So figuring out that molar ratio will be helpful in order to get to where we want, which is the concentration of the hypochlorite ions in the solution. So with this second relationship, which we can tell is a 1-to-2, as there is 1 mole of iodine reacting with 2 moles of thiosulfate, we are able to calculate the amount of iodine in the titration reaction. We only have to take the amount of thiosulfate and divide it by 2, because as established by the molar ratios and relationships, that will give us the amount of iodine in the titration reaction. That amount of iodine will be the same one as the amount of the hypochlorite ions in the original volumetric analysis that was run. Why? Because the coefficient of iodine as a reactant in the titration reaction is the same as the coefficient of iodine as a product in the volumetric analysis reaction. And since there's no coefficient change, and the relationship between iodine as a product and hypochlorite ions as reactants is a 1-to-1, the amount of iodine as a reactant in the titration reaction will be the same as the amount of the hypochlorite ions in the volumetric analysis reaction. So let's just go ahead and do that. We know that the amount of the hypochlorite ions is going to be equal to the amount of iodine, which is also equal to the amount of thiosulfate divided by 2. All of this we obtained from the molar relationship, so we just need to take that 0.00221 moles divided by 2, and that will give us the amount of hypochlorite ions in the diluted bleach solution. Now having that amount, we can now calculate the concentration. We know that concentration is the amount divided by the volume. The amount of those hypochlorite ions, we have already calculated it. It is 0.001105 moles. And moles is the standard unit, so we can just plug that in there. Now, the volume would be the one that is given to us here. It's 25 centimeters cubed of the diluted bleach solution. So that 25, as it is in centimeters cubed, we will divide it by 1000 to transform it to decimeters cubed before calculating with it, but it's that 25 that we need to use. So in the end, the concentration is that amount in moles divided by the quantity of 25 divided by 1000, and we get that the concentration of the hypochlorite ions in the diluted bleach solution is 0.0442 moles per decimeters cubed. Now finally, part D asks us to calculate the concentration of the original bleach solution purchased from the shop. Now, let's take into account the experimental procedure, the experimental method. It says that the bleach solution that was bought was diluted by adding 25 centimeters cubed of the bleach to a 250 centimeter cubed volumetric flask. All the rest that is not that 25 centimeters cubed of bleach is distilled water. So, the concentration that we have calculated right here of those hypochlorite ions in the solution is 10 times less than what it actually is, because it's been diluted 10 times in that solution. So in order to calculate the original concentration, the concentration of the original bleach solution that was purchased, we need to multiply the concentration that we calculated times 10. As we can tell that the differences in volume is a 10th factor, right? Is 10. So we just multiply that concentration that we calculated, 0.0442 times 10, and we will get the concentration of the original bleach solution purchased, which is 0.442 moles per decimeter cubed. So that would be part D, and I hope it was useful, and I hope that you learned more about how to play with experimental data and procedure. And again, the presentation is linked in the description if you find that useful. Thank you.